Hello, welcome back to BlenderSushi. Today we're gonna have a look at this tree generator script for Sverchok. It was being created by Elfnor. I think she's from New Zealand and she's like a maker or scientist as well. And she really has posted some really useful blog posts on Sverchok and generative art, including the things like L system, and she also helps making generative art node for Sverchok. The generative art is more similar to L system, where we have like a grammar to generate tree kind of form or structure. However, she also mentioned here that it has no provision yet for collision avoidance, so we might get a lot of intersecting meshes. So she researched into space colonization algorithm, and then there's also implementation of similar thing this by Farkan. It's called Space Tree. I think I probably wrote about it in my blog at some point. So we end up with this script node for Sverchok, treegenerator.py. Yeah, this is quite interesting to explore. Actually, you might be able to generate a lot of effects like lightning, or kind of like how can I say, like a growing vine kind of effects. And the cool thing about this algorithm is it will respect where each of the vine growing, so it will not intersect with each other. Yeah, so I will probably touch the basic and make a few videos, live noding videos, to talk about this. Yeah, let's just get started and have a look. So we are inside Blender now. In order to get the add-on, you get it from her GitHub. Where is it? Oh, there's an installation step-by-step instruction here. Download the tree generator from her GitHub, and this one, and then you just click on a clone or download and get the zip, and you unzip it, and I unzip it and rename it. Where is it? Sverchok. And should look like this with license readme. There's an example render of the tree. So you could apparently place some leaves, and this is the script py. Okay, let's just get started. Jump into Blender, and right away I'll jump into compositing. I have Sverchok installed already. Create a new node tree. I'm gonna save this really quick. So this is a SV Elfnor Tree 001. And do I need the cube? Maybe we can use this cube. Actually, let's hide the camera and the lamp. So we have this cube, and we have 1, 2, 3, 4, 5, 6, 7, 8. 8 different points. We can increase the subdivisions. We don't want it rounded like that. Maybe simple subdivision and then make a couple. Something like that is a good start. File save, and let's turn this guy into a wire. Okay, now we can start. File save. I'm gonna leave this one open and turn it into text editor and open up the script by Elfnor, this guy, treegenerator.py. So this is the Python script that you can read and you could probably tweak if you know, if you understand what it is. So yeah, with as you already know, with when you're doing live noding, not necessarily you will not be coding. Sometimes you actually want to do some coding, and then it's they both working together. With something like this, like a script node, you have everything being processed by one node, which is really handy. And then you can have a look, and then if you have some familiarity with coding, you can understand the inside what's going on, and this is the whole algorithm. So this is really valuable, you know. So let's this is Sverchok, and then script node. There are 3 different script nodes. This script will work with the first one. I don't know what the other 2 for. I think script 3 node is like if you want to use Sverchok kind of language to code mesh. They're still developing it. Script 2, I'm not quite sure. Maybe simpler for like a user to create like a interface. But scripted node 1 is the one that we use almost all the time for a lot of script. So this is the example provided by script generator, but we are gonna using the one from Elfnor. So let's load it, tree generator, and then just click on this plug. Now we have a node, and this node normally nodes, depending on the node, it has input and output. Of course, we want to get the output, right? So we need to provide some inputs. In this case, we have this is the parameters, and below we have the inputs node that we need to provide in order for this node to generate and output some results. End vertices, start vertices, and Elfnor given this example. Here, obviously, she has like a torus, and probably the starting point for the is from the center. But in her example, in this case, she has like she generated a circle, and then with 500 points, and then she randomized the circle, and using scalar to multiply the vector of the circle, she randomized. She creates like a circle scatter. And then she plug it into the end vertices. The start vertices is actually just a point. We're gonna do something similar to that. So start vertices is a point. In it's gonna be the center point. In the center there, I can view it using viewer draw. Plug that in, and then the start can have a vertex size of 10. So white, maybe not great, maybe I'll make it red. Okay, that's the starting point, while all the rest of the vertices of this cube will be the end point. So it's where all the tree structure will grow. Excuse me. So let's try I'm gonna get this cube mesh objects in, and get selection, and then post modifiers on, because we are using modifier to subdivide this cube. So it needs to be on so we can get all the points. We can check how many of vertices we have using list length, and stethoscope node in order to see the value right away. 386, that's correct. So plug in the vertices into end vertices, and by some magic we actually just now there's like a few seconds calculations, and this node is now ready to generate output. Let's have a look. Let's create a new viewer node. Plug in the vertices and the edges. Now as you can see, it generates something that looks like something underwater. What do you call it? Like a plants, the underwater plants. We get some points created. In fact, this looks also a little bit like neural inside our brain. It's really cool pattern. I really love it. Let me hide the cube for now. Yeah, that's even that structure is already quite beautiful, and you can perhaps print it out right away. This it respects the space between the points and where it's the direction is heading, and then it's also basically what Elfnor is saying in the documentation is that all the points here become the attractor for this. This is the starting points, red color, and then from there it's trying to occupy all the space and following the attractor points of the cube. Currently I'm asking her in her GitHub on how we can get more details, because at the moment it looks like a little bit spacey. I wonder if I increase the subdivisions and then update it, I wonder if I get more details. Apparently it doesn't. See, I don't get more details, but it's it generates a different structure. So that's kind of interesting. I was wondering if I can create more details and it will generate more. Let's go back to 3 subdivisions and then update it. So this result is quite interesting. Can we randomize it? Perhaps we can by shifting the list. So let me try doing that. Updating it. Apparently shifting the list won't do too much. Maybe shuffle. Plugin data. Shuffle is not doing much either because so yeah, of course, obviously it's looking at all the vertices and it generates these 3. Let me hide the points for now. So we have this structure, this is just the edges. We can of course bake it at this point, and then this is our first result, and that's really nice. You can use skin modifier to skin it, or you can, there's a faster way to get a form by using converting it to curve and generate a like a 3D that will render. So that's cool. This is I believe you can also animate this. Let me try real quick. Build modifier usually do the job for us. Okay, so that will work. Let's focus on this guy and then check the node. There is this option, another input node called Tropism. You can and you cannot. You can use this or not. This is like optional. Tropism, you plug in a vector, and from Elfnor example, I know that we can. Tropism is kind of like the force that's pulling the branches down. In this case, you can think of it like gravity. So we can give gravity of minus gravity that's pointing down in here. So now from the base points here, the starting points, all the gravity is pulling the plants to grow down. You can also put it up, so it's kind of like a, you can also think of it like sometimes plants follows where the light comes in, and it's always pointing towards the direction of the sun, which is a really magical kind of, it's a nature kind of thing. You can normally the tropism is pointing down for a tree, so that's a tropism. We can turn it off, and we have maximum branches, branch length, minimum maximum distance, and tip radius. This is will be related to the output. Let's focus on this tip radius first. It's 0.01. It's a small number, and should be careful. This is actually related to skin measure. This is skin measure is like a skin modifier, but inside Sverchok. It's actually using skin modifier outside Sverchok, but this is normally the last node you want to use. One of the nodes that can generate mesh. So you can plug in the vertices, and then it will need the edges. The matrix, we don't need it. There's a general radius, but normally this is a one node, one attribute we can plug in the radius kind of information. So branch radius, we can plug that in. Now, are we getting something? Not yet. We can remove double. We can add a material here. Turn on live modifier. I think when we turn on live modifier, it will now kind of output a B-mesh and then applying skin modifier on top of it. It might be heavy. I hope I have saved this file. Okay, it's successful. Good. Let me save it real quick. Save it again. So we can now, I'll hide the ghost, and then we have this something that's look like a ginseng, or like underwater plants. Ginseng, if you don't know, ginseng is like a Chinese traditional plant that grows. Ginseng plant. Usually it's it takes hundreds. These plants can grow hundreds and thousand years. So ginseng is really interesting looking plants. They say that if you eat this thing like 1,000 years ginseng, and you can live longer and keep young. But it's a Chinese tradition thing. But the ginseng, as you can see, the ginseng roots is resembling our tree. Yeah, maybe that's can be for another time. Anyway, let's focus on this. As you can see, with a skin modifier, skin viewer draw, we can have this kind of result, and this is respecting the output from tree generator. So that's really cool. Let's let me duplicate that, and can be pretty heavy. I'll just gonna kill the skin viewer draw node as soon as I duplicate this. The next thing we can investigate will be the maximum branches number, and also the branch length, and minimum and maximum distance. It's more like a trial and error. You can play around with that. And there's also leaf matrices. Before I forgot, there's leaf matrices, and then that's a really handy handy matrix information output to generate where you can put the leaves for the tree. So I'll kill the skin viewer draw. Now we have just this guy. Save again. So as we can see, this guy still have skin modifier and then subdivision level. I'll turn it to 0. Oh, apparently what's slowing things down is this skin modifier. This skin modifier is really powerful. As you know, it will turn edges into kind of skin mesh that has form and thickness. Can be slow, but you know, it does a lot of things underneath. It's doing this branching kind of thing. Sometimes I rather use curve, but that's the result we get. Looks really cool and complex, and you can further tweak it, you know, if you go to you can further tweak it if you still have the skin modifier. Sorry, I already applied the skin modifier, so that's why it's really fast. So we have this structure and that structure just simply by providing center points and then the mesh. Okay, let's back to where we were. Here, with the points in the center here, you can control it. Let's see if I'm using empty. And let's get the empty objects in, and Blender just crashed. Don't worry, I saved it. I think I saved it. Yeah, Blender crashes. Let's turn off Firefox. Okay, don't worry. Show package contents. Blender. Blender actually rarely crashes, but because here we are using Sverchok and then script node in Sverchok, sometimes it crashes. But Blender itself, without the add-on, is really stable. It hardly ever crashes. Gonna reopen it. It's gonna do the calculations for our tree form structure. Okay, now we get it. Save. Seems like objects in crashes. Sverchok. Maybe let's play with this first. Maximum branches 10. So that's 10 branches. But we can increase the branch length. So this is, of course, obviously, it's gonna be much lower resolutions. Turn on the vertices. So maximum branch, we can even just have like 3 branches. So it's counting the branches. So that's a single branch, and then 2, 3, 4, 5, 6. As we increase the branch, it's started to create more details. Depends on the branch length as well. Can have more or less. Smaller number of branch means more details. There's a minimum and maximum distance. That's that's I think related to depending on the starting points and then the ending points, we can kind of kill the influence. Maybe it's if the maximum distance is too small, these points cannot see the target points or the influence points or the attractor, so we need to increase the maximum distance. And then we can of course increase the branch length, not too long. If it's too long, we get like a scrambled looking. See the branch just confused, totally confused, going back and forth. It's basically going over the attractor points. So branch length, normally keep it low, 0.2, and then we increase the branching. So apparently this probably, if I turn off the points, maybe adjusting maximum branches and branch length will give you more or less details that you need. I kind of like the look that we have before. Now it's a little bit too scrambled. Maybe the branch length is too long. Let's try just oops, sorry, I have too big bit of shock there, but yeah, so we have this. So this is definitely lighter, so you can kind of tweak it to get like a very efficient kind of tree, and we can adjust the starting points. As you know, this is live, so we can start the points like that. The points can be tweaked live and we get different result. Sometimes I can see that something that's like a plane. No, let's see if I put the points out there. See if that's too far, it cannot see the attractor points. But if if I'm at the corner of this cube, and we can see that, yeah, it's kind of generating the thing that way. Let's suppose this is the object in and it's looking at the cube. If we turn off the pose modifier, we get a cube that's the basic cube with 8 corner points. We can use that as the starting vertices, and maybe we can see result. Let's turn on. Let's increase the maximum branches length. Maximum distance can be higher. Minimum distance. So I have a feeling that maybe a single point or a couple of points will perform better. I don't know yet. Maybe let's see if I kind of scatter points, like random points, maybe 3 points, and then let's have a look at the result. Not random, but a random vector. And then have 3 of points, and then let's have a look at the points. That's the points we have. It's randomly scattered inside within this boundary, and I've used that points, and we can see the result. Let me tweak this real quick. So that's a little bit better looking. So obviously you can have more or less points, and currently we have only attractor points on the surface of this cube. In order to have like a more like our brain kind of neuron pattern, we probably want like points that scatter inside inside of this object. So particles. So we're gonna be dealing with particles, right? So let me hide the original cube. Particle, original cube. You know what? I will use animation nodes, because animation nodes can handle particles a little bit better than Sverchok. There's a dedicated nodes for it. So now animation nodes, and we're gonna source this cube. Let's get this cube, and then let's create it. Mesh, object mesh in, object mesh data. Grab our cube. We don't need to generate every frame, maybe just when the frame is changed. Now we're gonna scatter. So this is gonna be a little bit advanced real soon. So this is the cube, and we want to get a particle. Get particles scattered inside a volume. Grid but slightly randomized. So here maybe resolution of 10 and randomize it. This is how I usually scatter inside a volume. We don't need to have normal. In fact, we can turn off the physics and we still have the particles, I believe. The particles should last throughout the timelines. Lifetime 250. Start and end. Yep, that's what I want. Maybe make lifetime 500. Okay, now we can bring in the particles into animation nodes. So particles, vertex locations, particles from object. Get our objects and we get a particle. We actually don't need these particles now. Particles, filter particles, that's the first thing to do. Only get a particle that's alive, and then particle info node, particle info and particle is info. Which one do we need? Let's take a look. Which one do we want? We want this guy. So particle is info is kind of like a loop in itself. We don't need, if we use particle info, we need to loop each particles. We don't need to do that. This guy will do it for us. And now we can output a mesh object output. Create a new target object, turn on mesh data, plug in that guy to that guy. And now back to Sverchok. Now we have the output as a mesh. Put it on layer number 1, and this is for Sverchok. That's our particle. It's basically baking particles into points. You can do that using Blender as well. It's up to you, but this is more live. Now back to Sverchok. Let's grab all these points, select it here, get selection, and now we have something that's a little bit more complex. reduce the length of branches. We have 3 points inside it. Increase the maximum number of branch. With this algorithm, apparently you don't need a high value of branches. You can increase or reduce it, but what it will do is based on these 3 origin starting points, it will look and try to occupy all spaces without intersecting. Let me see if I reduce the minimum distance. It's gonna be more complex. Maybe reduce the branch length further, increase the branching. I'm really careful with the numbers, so just in case it crashes. Maximum distance 10, maybe 30. So it's kind of so I kind of understand now. All of these numbers are kind of related to each other. The maximum, minimum, and maximum distance is like how far the points will crawl and search for result. If you imagine there's this is a starting points of an ant, and the ants try to occupy all space, but the ants never actually intersect each other when they're walking in this space. So there's kind of something. Maximum distance, maybe I increase it more, like 200, and maximum branches 250, 500, maximum distance 500. Maybe it will reach a point where the ants just died off. Maximum branch length 0.07. I kind of want this branch to really form the structure. I wonder if there's a limit in this. 0.1, 0.2. Okay, increasing the branch, don't quite like that. There must be kind of like a middle point. So it has no effects. Maximum branch 500. No, 200. Branch length. So my guess is that in this algorithm somewhere there's like a limit of how many iterations before it kills itself. NBP 2000. I'm kind of curious with this number, so let me increase it to 4000 and then reload this thing and update. Maybe now it's doing more calculations. Increase the branches, update. Maybe I increase it to 8000. Kill distance 5. Kill distance stands. And reload and update. Maybe it will generate more. Branch length maybe 0.03. Well, anyhow, let's just focus on one point. Anyhow, we can further tweak and get inside, but this should be like an introduction to Elfnor Tree Generator for Blender inside Sverchok. So if we have just a single point, which we can provide like 0, 0, 0, that should be the basic. Back to where we were, so we have this structure and we can, like I said, we can put some leaves for each of these branches. We can try just using sphere, for example, but sphere can be heavy, so rounded box may be pretty good. Let's try to see the output. So rounded box. Where's our rounded box? Rounded box need a vector size. .1. Rounded box. 22 radius. Vectors in 0, 0, 0. I just want to have this kind of sphere. So give it a color. For the yellow, turn off the wire. Turn off the points and turn on the light. No. So that's just the points. We can use this leaf matrices and plug it into our box, and we gonna get something like that. So this can be really nice, and we can render it out nicer using cycles, give it a random color. Anything you like, and that's kind of nice. If we have like a 3D printer and we can print out this kind of thing, that's gonna be so cool. The leaves can be also like just a flat leaves with a texture. Okay, that's the matrix we are getting from the output of this tree generator. But of course you can have like a circle polygon here, radius, degree, vertices maybe 8, and let's use this for our leaves, and we have something like that. That's also beautiful looking. Turn on the edge. Currently it's probably looking a little bit artificial, but still kind of nice. You can further randomize the leaves, and with the particles thing we can have the effect that's quite live actually. If I didn't bake the particles, so currently this guy is still looking at the particles, right? The particles coming from this guy, and we can randomize the seed of particles, and we go back and update it, and we get a different structure. For every frame we can perhaps randomize the seed and get a whole bunch of this generated mesh. I'm gonna give it a go. You might also want to try that. So anyhow, should be the introduction for this tree generator. There's a lot we can create just using this generator. As you can see, this looks like a lot like lightning. So lightning, if you think of it, it starts from a point, and then the lightning needs to reach that point, and along the way it's really trying to reach that until it reaches that part. It's creating this kind of tree structure, and then if I change the color of this stroke, once it reaches that point, the lightning basically travel second time and generate like a flash. So we can do that using this tree generator as well. I think super handy. All you need to provide is just a starting point and end points, but through everything in between. So yeah, but anyway, so I think I kind of explained the tree generator, the basic of it at least. There's also this end mask. Branch radius we already know. End mask, this is I think the end mask will give you a bunch of vector lists that you can use to further tweak and get the endpoints for each of these branches. You might be able to use that. Yeah, I guess that's pretty much it. Hope you find this live noding video useful. If you can leave comments and like, that will be awesome. And please subscribe to the channel for more live noding video like this. I'll see you next time.